Where's my picture? Mia.
Yes.
Did you get the picture?
Yeah.
All right, Rainier, how about you?
Yeah.
Soraya Fox, did you get the picture?
Yeah.
All right, cool. Okay, cool. I'm gonna move on then, since we have the picture of this. Sounds like most of you do. So this is a normal, actually, let me talk about this a little bit. This is a normal distribution bell curve, okay? Now, if you add all these up, 0.15, 2.35%, 13.5%, 34%, 34%, 13.5, blah, blah, blah. You add all these up, they're going to equal 100%. And this is going to be the area under the curve. Okay? This right here is called mu. Write that down. It's like a cursive U. This is the mean. So make sure you know that that's the mean of the data. You know, you have a bunch of data, you have the mean. So that means the mean of whatever data it is. If it's the height, if you have a whole bunch of people and you figure out the height, their mean is average, right? Mean means average. Their mean or their average height would be this number here, right? So say it's 5'10", okay? The mean. Now, this little O, write it down. Looks like a cursive O. That stands for sigma. That is standard deviation. Standard deviation. In fact, let's find where that is here. Standard deviation right here. Look, I'm highlighting it. That sigma means standard deviation. Standard deviations. Okay, standard deviations. Now, if you look at this, this is the mean. This is the mean plus 1 sigma. That means 1 standard deviation away from the mean. This is 2 standard deviations away. This is 3 standard deviations away. Okay? This is minus 1 standard deviation away, minus 2 standard deviations away, and minus 3 standard deviations away. I know you're thinking, what the heck does that all mean, Sensei? Well, standard deviation is just like the length from the data. If the standard deviation is small, that means most of the data is close to the mean. If it's large, it means it's far from the mean. But let's talk about, I know this is all sounds kind of unclear, but let's talk about like what this standard bell curve could mean. Okay? So, okay, let's go with Alan.
Yeah,
How you doing?
pretty good.
Am I making sense so far?
Yeah, a little bit.
What have you learned so far? What I've taught you so far? Tell me something that you've learned.
The stigma is the standard deviations.
Nice. That's good. 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 You can stop right there. Alondra,
Yeah.
what have you learned so far?
That all the percentage equal to 100%.
All right, cool. So we're learning stuff. Okay, thank you guys. So we have here, so I want to make sure everyone's paying attention. Now, the normal distribution bell curve, that's what we have here. I think this would make sense if we talk about it with grades. Okay, so let's say here, I'm going to do my mean. This is my mean. Let's say my mean is 75% for my grades at the end of the year. Okay, and then let's say I go here. I go 1 standard deviation away. And then let's go 2 standard deviations away, and then 3 standard deviations away. And let's say my curve looks like that. You don't need to draw this if you don't want. And let's say this one is here. There's 1 standard deviation away. I'm not going to really work with numbers here right now. I'm just going to work with grades. Okay. Let's say this section right here represents my A's in my class. See, that's my A's. Let's say this section right here represents my B's. Okay? And this section right here represents all of the C's. And this section right here represents all of my D's. And then everything left is going to be my F's. Okay? Now, what this is saying is, look at your curve. You guys see your curve that we drew there before? You guys see that? The one that I had you take a picture of? If this is a normal distribution, notice like this would be the other one here. There, this is all my A's, okay? My A's would be this section, this section, 2.35 and 0.15%. So what that's saying is 2.5% of my grades are A's. And right here, 13.5, it's saying, hey, 13.5% of my grades are B's. And then these two here, this whole section is 34% plus, you guys see that's the whole thing is 34% plus 34%. That means 68% of my grades are C's, 13.5% are D's, and my F's are going to be a combination of these two, the 2.35 and the 2.15. My F's are going to be 2.5% of my grades, right? So what this is saying is, hey, 2.5% of my class got A's, 13.5% of my class got B's, 68% of my class got C's, 13.5% got D's, and 25% of my class got F's. Now, let's say there's a story going on here. Let's say someone got an F in my class. Okay, you guys see this curve here? Let's say someone got an F in my class. I'm getting rid of the curve. I'm talking to you. Let's say someone got an F in my class, and their parents were like, man, that Mr. Sanchez, he's the worst teacher ever. He makes the students call him sensei. He does funny monkey noises in his class. Does he even really teach? I don't know if I like this sensei guy, this Mr. Sanchez. I think my daughter should not have gotten F in his class. I'm going to go talk to him, and I'm going to talk to the principal, okay? And so they'll talk to me and say, why did he give an F? Your class is unfair. And I'll show the principal my little curve here. I'll say, hey, Mr. Urias, I know you say that I'm unfair based on, I know I make the students call me sensei and have funny monkey sounds in my class. Yeah, but if you look at the data of my grades, I have a normal distributive curve. Look, Mr. Urias, look, 2.5% of my class have A's. A's are very difficult to get. So it's going to be hard to get, so it makes sense that less of my class has A's. And now look here. B's are a little bit easier, but you still got to work for it. So 13.5% of my class have B's. That means about 16% of my class have A's and B's. But look, 68% have the average grade of C. So most people have a C or higher in my class. Now this student here, there's only 2.5% of the people who have F's in my class. So if you study and you work hard, you can see that my class is a fair class because there's a normal distribution of grades. Okay? Now that is the normal the normal distribution bell curve. If everything is normal, that's what it should look like. You could see height, right? If we did that with height, you have a small amount of people that are very, very, very tall. Like how many people are as tall as, you know, Shaquille O'Neal, right? Not very many people, probably less than 0.15%. But how many people are about 5'10", right? More than 68%, right? So you're going to have people that are around 5'10", 6 foot, and then you have people like, how many people are as tall as Danny DeVito? You guys know who he is, right? Danny DeVito, woo, right? He's very short, but not many people. So he's going to be in the smaller percentage. So anyway, that's what that represents. Now, real quick, let's say, hey, Darshan, how am I doing?
Good.
Did you hear the monkey sound?
Yeah.
Do you like it? I could do it again.
Nah, it's okay.
Oh, I'm sorry. I thought you said you wanted to hear it. There's a monkey. I bought a monkey at the swap meet this weekend. Isn't that funny? They're selling them. They're little though. He's a lot. He poops in the kitty litter. That's fine, right? I trained him to do that. We had one accident on the carpet. I yelled at him and he went like this to me. Freaking monkey, you know what I mean? That's what I said. All right. So here we go. Now, what if my grade, my distribution of grades look like this? It wouldn't be normal. Let's say it looks something like this, and I'll draw it just real quick. What if it went like this? Woo! Whoa, hang on here. No, I don't like that one. No. Not that. What if it went like this? Right? And this is just a sloppy one. And let's say these are my A's, B's, and C's. And right here are my D's and are my F's, right? And the person said to me, hey, my student got a D. Your class isn't fair. And if I look, and like most of my students got only A's, B, like very few, let's say this was like 10% or less got A's, B's, and C's, and 90% got D's or F's, then guess what? Urias is going to beat me, right? He's going to say, you freaking stupid teacher, right? What's going on with you? It's not, it's your fault. It's not the student's fault, right? So anyway, normal distribution shows like everything's normal and fair, sort of. Everything's normal and fair. Now that you know that, what this tells me right here is, hang on, in a normal distribution, one standard deviation, this area is going to be 34%, this will be 13.5%, blah, 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 blah. You guys have the picture of that. We have everything that we need to know to do the homework now. Here we go. Let's look at where am I? Okay, number 3. You guys ready for number 3? Okay. What is the area? You guys have your pictures? Under this curve right here, this is a normal curve represented by the shaded region. Give the percent of the area. Notice they're asking for percent, right? So we're going 1, 2. Look at the standard deviations. There's 1 standard deviation, 2 standard deviation, 3 standard deviations, and 4 standard deviations. Okay, so that's number 3. What is the area in percentage? Notice it says percentage of 4 standard deviations away. Okay, so we have here, let me look at my curve. I have mine on paper. You guys look at yours. You have your curve there? So 4 standard deviations. Let me zoom it in. So that means I am going to add this number 3. 4 standard deviations. That's 34. There's 1 standard deviation there. So I got, guess what? 34% plus 2 standard deviations plus 13.5% plus 3 standard deviations plus 2.35%. Can you see me writing that there? And then the fourth standard deviation is 0.5%, 0.15%. Okay, so to find the total area, you just add all of those up. Okay, I'm going to give you 10 seconds to add it up, and then I'm going to call on one of you. I'm going to watch you guys. Look at me watching you. I'm watching you. What is the total area of that? I'm looking at you. You can see me looking at you. I'm looking at you. I only see, look at this. So can I pin other people on? Who should I look at? Gillette. Actually, I'm just going to stop the sharing. Okay, get ready. I'm going to call on one of you. Let's see. See if we can find someone who has their camera off. What's going on? All right, Johan, what'd you get?
I didn't get to write down all the percentages.
What the heck, this freaking monkey? Hey homie, are you looking at your let me see the picture you have of the standard curve that you got. Put it up there on your camera so I could see it. Do you take a picture of it with your camera? Well, you hold it up there again. Put it back up. I'm looking at it. Let me see, John. I want to see your notes. Is that the percentage there on the left side? You have the percentages. You need the percentages written down. Are they written there, Johan? Johan, are they written the percentages?
Yeah.
Okay, cool. So you just add those percentages up. I'll get back to you in a second. Coral, what'd you get?
I got 50%.
Perfect, 50% because it's half the curve. So the whole area is going to be 50%. All right, so that's number 3. So basically you just add those up, right? You get it? Bonnie, does that make sense?
Yeah.
All right, cool. Very good. Let's see. So let's look at, so basically, right, find the percentage and just add these up, right? These two up, right? It's going to be the 13.5 plus 2.35. But this one you have to add these up, right? Okay, I'm moving on. Let's look at number 7. Now look, this does it in a weird way. First of all, what 7 through 12 are asking. A normal distribution, that means you have the curve that you took the picture of, right, you guys? Has a mean u and a standard deviation sigma. Find the indicated probability for a random selected x value from the distribution. Okay, so this is asking for probability. This one before was asking for percent. Percent is in percent, which is what we did. Probability is going to be in decimals. You have to write it in decimals, okay? So number 7, now you need your little picture thing here. I'm writing this down, right? Probability of x is less than or equal to the median minus 1 standard deviation. Okay? So right here, number 7, what's the probability that x is less than or equal to the median minus 1 standard deviation? Okay? You guys have that written down? Okay. So let's see if we can figure out where that is. Probability, the median x is less than, so less than the median minus 1 standard deviation. So let's find out where median minus 1 standard deviation is. Okay, let's see if you guys can help me find the median minus 1 standard deviation. We're going to play hot, cold, right? You're going to tell me if I'm getting warmer or colder or warmer. Median minus 1 standard deviation. Who else shall I call? Let's go with Mia. Mia.
Oh, yeah?
Oh, there you are. Okay, help me find the median minus 1 standard deviation. Are you ready?
Yes.
Are you with me?
Mm-hmm.
So you tell me if I'm getting, you ever play warmer or colder? Like if you're getting closer to something, you say warmer, warmer, then you say burning up. And if
Yeah.
you're getting further away, then you say colder, freezing. You know what I mean?
Mm-hmm.
Okay. Do you know which one we're looking for?
Yes.
Okay. Tell me if I'm getting warmer or colder. Here we go. There's my pen. You see it?
Yeah. Older, older, colder, cold, cold, warm, warm, cold, 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 right there, hot.
Oh, yeah, burning up. I could feel it. So remember, they're saying X is less than this, right? See here, am I zooming in? X is less than, so very good. Thank you so much. It's less than the median minus 1 standard deviation. So we found that the median minus 1 standard deviation is here. It's everything less than this. So it's going to be 13.5%, or sorry, not 13, but 0.135 plus 0.0235 plus 0.0015. And I'll write that out in just a second. But basically, I'm going to add this area plus this area plus this area. Okay, because it's everything less than that. So let's add them up. And then I'm going to have you guys add it up for me. So we have 0.135 plus 0.0235 plus 0.0015. Can you guys see that? Okay, what is the area there? Okay, so go ahead and add it up. I'm going to call on one of you. Okay? But first, I got to feed my monkey real quick. Let me feed the monkey. And then when I'm done feeding the monkey, I will go ahead and I will call on the person. So, okay. Okay, wait. Okay. Here you go. Lucas, come here, Lucas the monkey. I can name my monkey Lucas. Lucas, no, Lucas, stop it. Lucas, Lucas, get off me. Lucas, oh my gosh. Hey, what the, oh my, ow. Lucas, get out of it. Oh, man. Oh, freaking Lucas the monkey. No wonder they're trying to get rid of it at the swap meet. I don't even know if Lucas is a guy or a girl. Man. All right, Johan. What'd you get?
I got 0.16%. Or
Don't worry.
0.16.
Don't worry, I'm okay. I'm okay. Don't worry. I know you're worried about me with the monkey. But we're doing it in decimals. What'd you get in decimals?
0.16.
Very good. 0.16. You all get that? Narith, did you get that?
Yeah.
Hey, Narith. Narith.
Yes.
Don't worry, I'm okay. I'm okay. The monkey, I'm not, it's not that bad. I know you're worried about me. You'll say, okay, that's cool, Sensei, or something. All right, so do you guys get that? So this is X is greater than, like, number 9. Number 9 is, what's the probability of X is greater than or equal to the mean plus 2. Am I on mute? I don't think so. Miranda,
Yeah.
can you hear me?
Yeah, we can hear you.
Okay, just want to make sure. Someone said asked if I was on mute. Am I on mute? Thanks, Miranda. Okay, so number 9, just real quick, and then number 9. Hey, what's the probability? I'm not going to solve it for you, but X is greater than the median plus 2 standard deviations. So where's the median plus 2 standard deviations? So we come here, greater than the median plus 2 standard deviations. It's here, and everything greater would mean we add this and this, right? Make sure it's in decimals. Are there any questions? Going to move on to the next problem. Move on. Lucas! What the heck? My gosh. Okay. Was that too fast? Am I going too fast? Soraya Inez.
Yeah.
Am I going too fast?
No, it's fine.
Are you sure?
Yeah, I'm sure.
What if I was going too fast? Would you tell me?
I would.
Tell me something you learned today?
Oh, sorry.
Whoa! Hey, let me hang on. I'll get that dog. Hey, get him. Soraya, sorry. Did my monkey scare your dog?
Yeah, I think so.
Tell me something you learned today.
I don't know.
You haven't learned anything?
I mean, I learned.
Wait a minute. I need to look at you. Hang on. Wait, what? Have I not? Hang on. Soraya, am I going too fast?
I don't know. It's just like completely a new lesson for me, so I'm just trying to.
But you didn't learn anything today? I didn't teach you anything?
You did teach me.
Well, tell me what you learned.
I don't know.
What? Oh my gosh. Soraya, I am so sorry. I'm sorry. How could I be a better teacher? Tell me, please.
I don't know.
What do you mean? Who did you have last year? I could be like you. Did you learn? Who was your math teacher last year?
I had two teachers. I don't remember one of the name, but I think one of them was Krieger.
How can I be more like Krieger? He is such a stud. You know he can rap. Did you know that?
No, I didn't. I know he could
He's
sing.
never rapped for you?
He's-
You ever do the one-handed push-ups?
No.
You never did them? Has he ever sang songs for you?
Yeah.
There you go. Have you ever seen him? Did he tell you how good of a bowler he is?
Oh yeah.
Yeah, that's what I'm talking about. I'll take bowling. Johan, have you learned anything today? I'm not sure if you're there because I can't see you, so I'm going to keep calling on you. Have you learned anything today, Johan?
Yeah.
Tell me what you've learned.
When you add the percentages from one of those graphs thing, it adds up to 100%.
Very good. Soraya, did you hear what Johan said?
Yeah. No,
What did he say?
I didn't hear him.
Okay, Johan, say it again so Soraya can hear you.
When you add up all the percentages from that one bar or graph thing, it adds up to 100%.
Oh yeah.
Did you get that?
Yeah.
Okay, I want you to repeat what he said, Soraya.
All the percentages on the graph add up to 100.
Yes, Johan. Johan, how much money do I owe you? Because you just did my job for me. Soraya, pay attention, okay? Here we go. So basically, this is what's the probability? Wait, I'm not sharing now. Darshan, how are you doing today?
Good.
Did you learn anything?
Yeah.
All right, what'd you learn?
All the percentages added up equals to 100.
That's the only thing you learned, what Johan said? Okay, but anyway, so this is probability of x is greater than 1 standard deviation, 2, we already did that. Okay, so let's talk about this. A normal distribution has a mean of 33 and a standard deviation of 4. Okay, so what this is saying is we need to draw our own new curve, okay? So you guys draw, so it has a mu of 33 and a standard deviation of 4. Okay, Soraya Yanez,
Yeah.
what did I just say?
You read the problem.
But what did I say in the problem?
That the mean is 33 and the standard deviation of 4.
Very good. Okay, so here we go. So that means we have to draw our bell curve. Everyone drawing this bell curve here? Soraya, are you drawing the bell curve?
Yeah.
Okay, cool. So I want the mean to be 33. That's what it's telling me. And then my standard deviation is going to be 4. So this is 33. What do you think this number is going to be next if my standard deviation is 4? I haven't taught it to you, but see if you can use your deductive reasoning to figure it out. Let's go with Silvana. Okay, if my standard deviation is 4, what do you think this number will be, Silvana? I haven't taught it to you, so if you don't know, I want you to try to figure it out, though.
Is it 37?
Yes, very good. We're going to add 4 to each one. So my standard deviation is 37. And then my next one over, I need 3 of them. So there's 2. What's this one going to be? Let's go with Tommy.
I don't know.
What? Tommy, you can't just say that. Tell me what you're thinking.
I'm still writing down everything.
Okay, I'll wait till you write it down. Tell me when you're ready.
Okay, I'm ready.
All right. Tommy, what's this next number going to be, do you think?
41.
Yes, because we're going to have a standard deviation of 4, so we add 41, and then we need our third one, which we'll put right about here. Thank you, Tommy. Let's go with, let's see, Monica. What's the last one going to be? Is Monica here today? Juliana.
The next one will be 45.
45. We're adding now. Let's go in this direction. So what's this number going to be here? Okay, let's go with Jason.
What was the question?
Jason, stay with me, okay?
Okay.
Gabriel. We're going to get to Jason in a second. What's this next number going to be, Gabriel?
Uh, 29.
29. Tell Jason how you got that number.
I subtracted 4.
Yes. Or how you say 4 in Spanish is corazon, I believe. Corazon is how you say 4 in Spanish, I believe. Jason, what's this number going to be here?
Is it 25?
Very good. And then we have one more. I'm just going to say we have here 21. So we made our curve based on the information that they said. We have a median of 33 and a standard deviation of 4. That means each of these increase by 4. So here we go. There's my curve. Now, if you look at your phones, like I said, right? So you got to figure out the areas of these, right? So this is, remember, this is 34%. This is 34%. Now remember, this is right here. We have 13.5% for this one, right? We're building it. You got to build the curve in order for us to answer this. And then we have here, this is going to be 2.35 and then 0.15. And then here's 2 point. Can you guys see what I'm writing here? 2 point. Based on the, you guys see this on your phones. And then we have here 0.15%. Okay, so anyway, there's my sloppy little curve there, but that's going to help us answer our questions. All right. Miranda,
Yes.
am I going too fast or should I pause a little bit?
No, you're good.
Okay, anyone else? Should I go? Can I go? Okay, I'm moving on. Now let's answer the questions. If you guys have that drawn, you should be able to work it out. So what's going to ask is, find the probability, now it's not percentage, so we have to do it in decimals, that a random selected x value from the distribution is given in the interval 29 through 37. Okay, so what's the probability that I'll get something between 29 and 37? Okay, I'm kind of have it sloppily written down here. I'm going to ask you guys, what's the probability that I'll pick a number between 29 and 37? Okay, so what's it going to be? You guys ready? Write down what your answer, you think your answer is going to be. I'm going to call on one of you. I'm going to call on someone at random. Totally random. This is totally random. Are you guys ready? Speak up if you need more time. All right, Soraya Yanez, what'd you get?
Is it 68%?
Very good. Actually, Soraya Yanez, you're almost right. It asks for probability, which you're going to do 0.68. If it asks percent, you do percent.
Okay.
All right, very good. Thank you so much. Okay, so that's pretty much most of it. I'll leave that there. I'll leave there for another 10 seconds. Okay. Let's go with, that's that. And then, so like this one, the problem solving, the wing lengths of houseflies are normally distributed with a mean of 4.6. That means you put 4.6 as your mean, and then you're going to, for each standard deviation, you keep adding 0.4. So it'd be 5.0, then 5.4, then 5.8, and you go the opposite direction. And then you can answer these questions once you build that curve. Let's see. And the last thing, let's talk about, this is the last one I'll do, and then I'll let you go. If someone can get this right, I'm going to let you guys go. In exercise 21 and 22, we'll just do 21. A normal distribution has a mean. So what's wrong with this curve, right? A normal distribution has a mean of 25. Okay. Does that do a mean of 25? And a standard deviation of 2. Okay. Does this have a standard deviation of 2? Now correct the error. So as a normal, a mean of 25 and a standard deviation of 2. Okay, so what's wrong with that image? Here we go. I'm going to call on one of you. You guys looking at it? Think about it. What's wrong with that image? I'm going to call on someone at random. Lucas! Stop it! Oh my gosh. Okay, what a mess. Okay, I got to clean this mess up, so I got to get this thing done here. Okay, let's go with, hey ho, Edwin. Wait, where am I at? Sorry, Edwin, I'm on the wrong thing. Edwin, are you there? There it is.
I'm here.
All right, what's wrong with this picture?
I don't know.
Edwin.
Yes.
Okay, homie. This has a normal distribution with a mean of 25. Is my mean correct in this thing here?
Yes.
Where's the mean? Tell me about the mean and the normal curve.
The
Normal
25
distribution
25 is like right there. It's in the middle.
should be in the middle, and it says that. Okay, so that's good. That's correct. And a standard deviation of 2. Is this putting a standard deviation of 2?
No,
How do you know?
because it goes from 25 to 26.
What should the 26 be?
27.
Very good. And then this number should be what?
29.
That's the error. It has a standard. What does this have a standard deviation of?
1.
Yes, and it should be 2. There's your answer. Very good. Okay. I always like, whenever I say bye, see the first one, like some of you leave this class like a bat out of hell. You just go, okay? But I've taught everything that you need to know. Are there any questions? Okay, let's see who goes first. All right, see you guys tomorrow. See, first one out is Michelle Covarrubias, Tommy, Rainier, bye, Darshan, Caleb, Bonnie, bye, Alex, Roberto, Mia, bye, Andres, bye, Gabriel, bye, Saledmi, bye, Soroya, bye, Alex, bye, Jason, bye, Manelli, bye, Sensei. Wait, I'm leaving? I'm not leaving.
Hey, see you later, Sensei.
All right, Henry, take care, man.
Hey, you too, man. See you later.
All right, have a good day.
Thank you.
Edwin. Edwin, I think you're gone. I'm going to hang up. Oh, Edwin said bye. So I'm going to go.